Welcome back. So I decided to make a power supply for the Commodore 64, and I think it was about time to do that. I do have two power supplies and they work fine, and I do have a saver that I made myself, but I think maybe having one with a display that shows like the voltage and power usage, so I'm not that afraid for overvoltage on like the one you build yourself, which is new. But if you have a Commodore which is broken, or the current draw can be like an indicator for that. Like for example, if the chip has been shorted internally or something. So yeah, so this is the power supply. It's not completely finished, and this is a very nice connector. I can link all of these parts in below. Let's have a look inside. So, but first let's have a look at the back. So I had to cut this hole myself. I bought this tool, but I haven't got it in the mail yet. That you can nibble out square holes. So these are just me clipping with some overdue side clippers. So yeah, so basically you have 5 volts. It's a mean wave power supply, 3 amps, 5 volts. So you have mains coming in and earth, and then the mains is also going over here. It goes into the fuse and then into 230 volts. Let's have a look at it. So I have an itch. So the transformer is 230 volts, 10 volt amperes. So about an amp. Yeah, so I have a fuse. It's a really nice fuse. I think it's just a fuse, but I thought it was cool with this cover on it. So yeah, and then basically that's it. And we have mounting posts. And you can see underneath we are having spacers. This, and then we're gonna have nuts tying them down, so you can put it together, screw it tight, and then you have a power supply, right? So, then later you can have like a display. So I ordered an OLED display, but I have lost it. It's so silly. And also I want current sensing, so I've been playing with this. You may recognize text that's on it right now. It says help 8765. I will link in the video below the person who has done it. Okay, it's not a secret. It's Julian Eilert, and it's directly from his video. The only thing I changed in his code was pins I've used. E connector is in, switch is in, power switch. Maybe you can tell that I hate working with metal. So basically I have used my previous, I have a new one, so I can just use this for whatever. I have basically just cut the holes like a scissor. So here you can see what came out. I've been drilling also. It's all stands like this. I have little nuts going over there. 9 volt in, fused, 220 fused into 230 out, 9 volt out here to the plug. And this is the 5 volt
insulated. However, you can see there are some metal here which is not insulated, like underneath here. See, the plug is not in, so no problem. But I don't like that anyway. So, didn't turn out too bad. It's a bit how you're doing. So, I found this tool online. It's this one. It's called Nibbler Tool. So basically what you do, you can see it on the picture there. Just when you press it together, there's like a nibbler there, so you can nibble away. So it's easier to make square holes like this. So if you look here, you can see it's not very pretty. But if I have had this tool, it would have been really pretty. So yeah, it's not too expensive. So I didn't show any of the build, but I recommend people who know what they're doing to do this. You don't have to do it like this, you can do a much simpler build. And I was thinking, okay, so now I've done this and it works. Now I can add like a power meter or something with a relay or something. So I can switch it on and off. I don't know, maybe power saving, but it's not really needed, I think, with this power supply from Meanwell.
So I was thinking, maybe I can use large digits instead. It's like, I have two of these. We can have voltage and current, and then maybe power. But power is just a measure of voltage and current. It's not that important. I was also thinking having measurements on the 9V also, but it's not that important either, because it's just a transformer. It really goes wrong. So, and then you have in the middle there something called ENA 219. So that's the name of the chip. In the middle you can see the largest chip. So basically this is just a resistor, this is the chip, and you have a current sense resistor, which you can take on the high side. That means on the 5V line you can connect the power supply in here on the plus side, and then the load on the negative side. And the plus side is measured for voltage. I think it's the plus side anyway, and the negative is fed through. Yeah, so the current comes in here and then onto this pad through the resistor and then out again. So basically these two looks like a short, but since they go through a very small value resistor, there's an operational amplifier in here that measures the difference and converts it into a current measurement and also voltage measurement. And then it has I2 square, I2C, I squared C, I don't know how you say it, bus. So the data is just two lines, and of course voltage, you need voltage, and power. So that's very easy to do. So, and I was thinking, okay, if I want to measure the 9V, I still need isolation, right? The transformer, but so I2C is really easy to isolate. If it's not easy actually, but because it's bidirectional, but you can get chips and it's just two IOs, clock and data. So that makes it perfect for isolation. So I might do that. So, because the thing is that you can have the Arduino on powered by the 5V, and then on the 9V you can power it by the 9V, and connect it with I2C. So the current sense will be a standalone module. But I think I will skip that. So I can test the power supply now, see if it works. I think maybe this display will be very large, so I don't know if I have space for it either. Look, it takes this much length, and at the end here I have this big ass transformer in the way. This box isn't really that suited for what I've done. I could have done differently. I could put this one on the side, right? I could have had a separate board with this one on, or I could glue this with epoxy upside down there. So there we go. So if you had the display here, it will touch this side. So you see the line down here which goes there. That's where the front plate will go. Like this, it's the same plate as the back. So that's a problem. What I can do is I can make new holes for this board, move it a little bit back. Actually, that I can do if I want this display in front. I could mount it like this. It's not really that big of a problem, but it's a bit silly having a display on the side. I don't know. Anyway, so it will be like a grommet, and then you will have like digits. However, anyway, so let's talk a little bit about the power measurement. So let's try and get a measurement out on this thing. I have tried. This is the Julian Illet example, where you get for fun we can now try measure the power through this one and see if we can see something here. So what we need is well, what I've done, I have a little load here. So there it goes out again. Yeah, so let's try this thing. I can try it with a Commodore 64, but first I just want to try it with a dummy load. So this is the dummy load. It's just a resistor. I think it's 560 ohms. Yeah, so this is how I hooked up the power meter. It has data, it has VCC and ground to power the chip, and then I have this dummy load here. So we get 5 volts in on V in plus, and from V in minus, which is after the shunt resistor, it goes back to ground. So basically you are loading this shunt resistor. So that's the point. So imagine this is the Commodore 64 side. So there will be like 8 milliamps or something like that. And that works. So I've tested that with a program I found online. I will link it down below, that too. Really nice with Arduino. It's so much help to get out there. So you just have to address them. So if you have a second one, you can put a solder blob on the A0 there. So then you get a new address for the another current sensor. They have registers. You just ask for current, and you can ask for voltage. And you can calculate power. So I've tested this and it works fine. So I get 8 point something milliamps out of this, and if I pull it out, you can see it change. So I've only seen that through the serial port or the virtual serial port. But now let's try get it out on the display. So the code I got from Julian Illet's website or YouTube video, it writes digits directly, so it also uses decoding, in decode mode register. That means if you send 5 in, it will actually display 5 and not just turn on the corresponding LEDs. So this is the INA code. It's very small. Use Adafruit's library. So you just instantiate, you initialize, and then you can then you use that instantiation to get what you want. Now, printing it out is a different matter. So here is the spliced code. It sets the shift select low, shifts out data, first the address, then the data, because it's 16-bit transfer, and then it turns off the shift select again. So that's how we use output. He had everything in setup, but I have taken away the data that is written in setup because we are going to do it in the loop. So there you have it, a little bit better. The voltage is now coming from a power bank, so I can added 5 pieces of this captain tape on top of each other. It cancels out ambient light, so that works really great. So let's try making it pretty. So last night I did this board. So the idea is that this display is a bit recessed. Need a little notch. You see it's a bit clumpy. But I do like it a little bit better. I can sand it down and make it smooth and everything if I want. So the problem I have now is that if I put the board in here, still see if I hold it a bit up, you can see I need space. I need about 6 or 7 millimeter for the transformer there, and you can see I can move this back a little bit. Yeah, so you see there's more space to the transformer anyway. So I think we'll do that. I'll be right back. When I programmed this, I had to make like a finite impulse response filter, basically a filter, because when I measure USB voltage, it jumps very much up and down, so it's very unstable. So I have filtered it digitally, and I wonder, when I switched it on, you can see that it's moving a lot. I think maybe, what does it look like if I turn off the filtering? So let's do that. I will program it and then come back. Finite impulse response filter is. So it's very, very simple. It's a rolling average. You know average? You take a bunch of numbers and divide by the number of numbers. That's the average. When you do a rolling average, you update it. You don't keep storage of every measurement. So what I do instead is that I take a percentage of the old one and then the rest multiplied by the new one. So this is the raw value, the noisy one. So that's only 10% of the new one. Is then put together with the old one. So that will be 90% of the old one, or the average, old average, not the old one. So here's voltage and here's current, and that's what goes to the screen. So let's just write, yeah, so you see I'm not using average for current there. So let's see what happens if we set voltage to raw instead. Oh yeah, so it's not in scope, so voltage raw is here. So basically what we need to do is just, now it should compile at least. Current round raw. So it says current was not declared in the scope. Well, it is actually declaring it, so what's the problem then? Well, we're missing a semicolon. That's very typical. Error messages are not always so helpful, but you get used to it, I'm sure. Update rate. Now something is wrong about that too. Defined read only. Aha! Yeah. So actually I was trying to put it as close to the code that I was using it. That's why I had it like that. So yes, it's a constant, of course. I can't update it further down. So there you go. Let's remove this line. Okay. Let's go again. Voltage row was not this clear in the scope. Okay, so I've cleaned up a little bit here. So because I was testing something before, I never put it back together or clean it back together. So yeah, so here you go. If voltage average is larger than 0, if not, it just sets it to roll. And the reason for that is because when you have a rolling average, it has a tendency to move very slowly. It depends on the rate you're setting. And then if it starts at 0, then it will take a bit of time, or not much, but it looks like it starts at 0 and then rolls up. So now it starts at the raw and then rolls to the average. So let's see if it looks for the board. If it looks for the board, I'm going to take this, yeah, it does, but it doesn't do anything. So what I need to do is to hit reset at ground at the same time, twice, and then, look, it programs. So here you go, now it's running, and okay, so let's turn on the Commodore. So I think that the L01 was actually a negative value, so we don't need that. So yeah, look, it's fairly stable. This is without any anything of this rolling average, as you can see. This is what's printed out, because we are making it into an integer and rounding, and we're using raw values. But now I'm going to try just replace those with average, and we're going to make it a little bit crazy average. Just up here you can see 0 or 1% here. So I need to program that. I need to shut off power, take this one out so I don't hurt myself. Insert the cable, down, back in again, and we're back with averaging. So look how stable this one got. I think it rounds it to 0, not 0 minus 0 point something. So yeah, let's try turning it on, see what happens. Yeah, okay, so you can see the rolling average. Chuk, 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 like it's going down slowly, and then when I turn it off it goes up slowly. But in reality it goes much faster. But I don't think that's 1% update for every sampling is a good thing. So let's try 10%. So same procedure, program, hit reset twice. This, confirm, yeah, it's programming. And there you go. So let's try it again. See? That's better. Okay, I've inserted 220 volts. Now you can see the current is working again. Let's push on the Commodore, and there you go. Yeah, it's bouncing a bit up and down also with the... But now this one is not bouncing anymore. Remember, it was bouncing. Let's just insert a clip. I don't want to program it once more. So you can see how stable it is. Maybe you don't want that. I like to have stable numbers. So switch it off, see it goes down. Yeah, you can see it has an overshoot on the current there. Switch it on. That's normal. So yeah, I'm happy with that. So thank you very much for watching. I hope you liked that. So this is the ending of the video, and the next video will be of a C64 Saver or the Nunchuck Nintendo wireless board for the C64 from Toulon. So hope you liked it. I hope to see you again soon. Write in the comments. See you another time. Bye bye.